Komisar, and in addition to being an engineering PhD student at Toronto Rehab, I also spend a lot of time on developing mobility aids. The major purpose of this product is to develop a way of giving people stable support for getting out of bed, and it's designed with institutions like hospitals or care facilities in mind. Clinicians approached us and asked if we could design a pole that you could install without having to drill into the floor or the ceiling, and that you could remove and store somewhere else when it's not needed. They found that a lot of the residents were having trouble getting up and around, and it was really putting a strain on both their care practitioners because the nurses are quite understaffed and at risk and can't always be around to help a patient out of bed. And for residents, it was really difficult because, say, instead of being able to do things that you could do independently, like go to the bathroom, if you're stuck in bed, it becomes a bedpan and the situation just becomes challenging. So my role in this product was in ensuring that it was safe for a lot of big range of people to use, so this being light users, heavy users, users with arthritic hands, just making sure that it was safe for diverse populations. We actually went and built a wall in the basement and pulled on this to make sure that it could support the really intensive loads that someone might put on it when transferring in and out of bed. For the testing, it's actually surprisingly difficult to figure out how you can design a pole that you attach to a wall and make it stay in place without ripping the pole out of the wall. You know, you can see that it's fixed to a track that's there. It's not a trivial task, and we actually use a lot of finite element modeling to design the track. What's great about working in a hospital here is that clinicians will sometimes bring their patients up to try it out. They might have a patient who wants to practice getting out of bed with a pole before they go home from the hospital. I'd say getting to that point was a fairly rewarding part of the process. We were able to get feedback that informed design changes and helped us to make the product better. And we were also able to see someone get out of bed on his own for the first time in quite a few weeks. Similarly, we had to figure out how you could remove the pole from the wall when it wasn't needed. And this would be a case if you had a new patient come in who could get out of bed on their own or just simply wouldn't be able to get out of bed even with a pole. Because at that point it becomes an obstacle for others in the hospital and for medical equipment and for anyone on maintenance or housekeeping who has to clean the area around the bed. The track serves two purposes. The first is that it allows you to remove the pole itself quite easily without having to unscrew anything. You just need to loosen bolts there. The other thing is that it provides the stiffness needed to keep the pole in place and stop it from ripping out of the wall when a heavy user tries to get out of bed. One of the other challenges on our end for this project was developing a good grip section that patients could use as support for getting out of bed without it rotating around the pole or without having their fingers slide down it, to ensure that it met the required infection control standards. So a lot of other poles on the market will use foam, for example, as a grip sections on the pole. And that was a complete non-starter with our infection control team. So we knew that we had to ensure that the product was cleanable enough to be safe for use in a facility. The challenge, of course, then becomes making sure that a person's hands don't slip down the pole when they're trying to get out of bed and when they're relying on this to pull their full weight up. So from that, we came up with this knob design or bump design, and we actually tested a few different concepts out among others in the hospital. We had something with bigger bumps, something with smaller bumps. And this was sort of the contour that was comfortable for someone to grab, even if their hands were sweaty or covered with water or soap or something slippery like that. When we were designing StandEasy, one of our big priorities was durability. So making sure that the product would withstand and stay safe and not break even after lots of different people used it, or when it faced the, I guess, bumps that would come with someone coming in and cleaning around the bed or bringing a vacuum cleaner and hitting the pole by accident. Locking these grips in place, we have mechanical stops up here that stop this from rotating around the pole. The other thing we did was we ensured that the arms here were strong enough so that they wouldn't fall down even if someone stood on the arm or swung off of it. You know, say kids are going to visit grandma in the hospital. They see apparatus looks like a jungle gym beside her bed. You never know what's going to happen. For this, we actually suspended quite heavy weights off of each end here. We were able to achieve fairly high loads, and that gave us a lot of confidence that this product would not break even after taking abuses that would go beyond normal sitting to standing. So by cross-sectional design, we mean what shape is the rail or handhold, how is it shaped, how big is the diameter or perimeter, and does that design align with something that someone could get their hand around if they're trying to use that handhold for safety and recovering from a balance loss. The other part of the testing process was in getting data to understand what a person would realistically be loading onto a pole. So, after a year, we were able to conclude what sort of loads it could resist before failure. I'm really proud of how we were able to involve a lot of clinicians throughout this design process in developing StandEasy. They were able to inform features like ensuring that we had grip sections all throughout the length of the pole. When speaking with occupational therapists and other clinicians, one comment we often hear about other poles on the market is that the grip sections are way too high. So if someone is reaching over the pole from bed, they don't touch a nice foam piece to grab onto, they just get slippery steel. A major priority in the clinical community is ensuring that their practice is based on evidence, and not just any evidence, but the best evidence possible. And as developers of medical devices, we think it's really important to ensure that this evidence is also reflected in the way we design our products. So we're really proud and excited by how a lot of our recommendations were adopted in the design of StandEasy that's being released. There wasn't a standard for us to work with in this case, so we went out and collected biomechanical data and broke a lot of poles in drywall to ensure that designing a pole that supported the wide range of users that it would support.